Good morning, students. Today we are going to discuss about resolution of a vector and dot product. So let us see what is resolution. Resolution of a vector means it is the process of splitting of a vector into two or more vectors in such a way that their combined effect is same as that of the given vector. For example, if I give one vector in any direction, see, I am just making a rough figure here. If I draw a vector here, see, for example, this is vector A. I can split this vector into two components or three components. So I just do it like this. Vector A is split into two parts. Now I draw like this and I draw like this. This is marked as AX, this is marked as AY. So I can write AX plus AY is equal to A. This is called splitting of a vector. So what I actually did is, when I draw a vector A, I split that vector into two vectors, vector AX and vector AY. This is called resolution of a vector or splitting of a vector. And the vectors into which the given vector is split are called component vectors. So AX and AY are called the component vectors of A. Now what is meant by rectangular components? A vector is resolved along two mutually perpendicular directions. The components so obtained are called the rectangular components. For example, in my above description, I just told vector A is split into vector AX and vector AY. Both are mutually perpendicular. So AX and AY are called rectangular components of vector A. So that is what the definition says. So rectangular components means a vector is resolved into two mutually perpendicular directions. The components so obtained are called rectangular components. After viewing the video, please take down all the notes. Okay, don't forget any points, because what all things I am displaying on the board is actually your notes. So you have to copy all the notes from the board. Listen here. Rectangular components of a vector in two dimensions. So what I am doing is, I just took a vector A, which is this is vector A, and I am going to split this vector into two parts, vector AX and vector AY, AX and AY. So these two are called the rectangular components because AX and AY are mutually perpendicular to each other. Now I just draw the parallelogram here and here. I took the parallelogram and this became the resultant. So now I can write vector A as vector AX plus vector AY. Now what is vector AX? As I told you, any vector is having magnitude and direction. Every vector will be having magnitude as well as direction. So the magnitude of vector Ax is written as Ax and direction of vector Ax is written as I cap. So vector Ax can be written as Ax into I cap. Similarly, vector Ay, magnitude is Ay and direction of vector Ay is j cap. So vector Ay can be written as Ay j cap. So vector A is Ax I cap plus Ay j cap, where Ax and Ay are the magnitudes in the x axis and y axis respectively. Now, how will you find the magnitude of the resultant? Magnitude of the resultant is modulus of vector A, or simply you can write A. So A is equal to root of Ax square plus Ay square. This we studied in the previous video, how to take the resultant if two vectors are perpendicular. Root of Ax square plus Ay square. Similarly, how will I find the direction if two vectors are perpendicular? Tan theta is equal to Ay by Ax. So from there, theta is equal to tan inverse of Ay by Ax. So using these two equations, you are able to find the resultant, the magnitude of the resultant and the direction of the resultant. Now, a very important point. Look at the triangle OPQ, this triangle OPQ. From this triangle, what is cos theta? You already know cos theta is equal to adjacent side by hypotenuse. So what is the adjacent side here? Ax. Hypotenuse is A. Therefore, cos theta is Ax by A. So Ax can be written as A cos theta. Similarly, from the same triangle, what is Ay? Ay can be written as A into sin theta, because we took sin theta as opposite side by hypotenuse, that means Ay by A. So Ay is equal to A sin theta. Okay, so what I want to mention from these two expressions, whenever, listen to me very carefully, whenever a triangle is given or whenever a vector diagram is given, and if I mark an angle, say theta, if I mark an angle in the vector diagram, then the side adjacent to that angle, the side adjacent to that angle is cos component and side opposite to that angle is sin component. So here is the angle I have marked, right? Here is the angle I have marked. So side opposite to that, side adjacent to that is the cos component. So Ax is equal to A cos theta and side opposite to that will be the sin component. Ay is equal to A sin theta. This you have to remember till you complete your +2. So in almost all the chapters we will be using this concept, so don't forget. Side adjacent to an angle is the cos component, the side opposite to the angle will be the sin component. Okay, so that is all about vector resolution. Now we are moving towards the third thing, that is scalar product or dot product. We studied vector addition, and when two vectors are perpendicular we use the equation using triangular law or parallelogram law, we use the equation root of Ax square plus Ay square. So that is how vector addition is done. Now how can we multiply two vectors? There are two different methods of multiplication. The first one is called scalar product or dot product, and the second one is called vector product or cross product. So here we are going to deal with scalar product. So what is meant by dot product? If the product of two vector quantities is a scalar quantity, then we take dot product. If the product of two vector quantities is a scalar quantity, then we take dot product. See, for example, you know work. You have learned in 9th standard, work is the product of force and displacement. Force is a vector quantity, you know it. Displacement is also vector quantity. But you have studied in class 9 that work is a scalar quantity. So, force and displacement are vector quantities. Those two quantities are vector quantities, but their product is called work, which is a scalar quantity. So, if the product of two vector quantities is a scalar quantity, then we will go for dot product. How will I define dot product? Dot product is defined as the product of magnitude of two vectors and the cosine of the angle between them. The product of magnitude of two vectors and the cosine of angle between them. Look at the equation. Here I have written vector A dot vector B. Don't read it as vector A into vector B. We are learning dot product. So, you have to read it as vector A dot vector B. That is equal to magnitude of A into magnitude of B into cos theta. So, vector A dot B is equal to AB cos theta. That is the equation. Examples for dot product. I have given two examples. First example we have already discussed, work done. Work done is equal to force into displacement. So, I write W is equal to F into S. W is equal to vector F dot vector S. You can only read it like that. Don't read F into S, you have to read it as vector F dot vector S. Similarly, the next thing is instantaneous power. Instantaneous power can be written as P. P is equal to vector F dot vector V. Okay, it is the dot product of force and velocity. Force is a vector quantity, velocity is also a vector quantity, but power is scalar quantity. So, P is equal to vector F dot vector V. Now, we are going to study the properties of scalar product. So, the first property is scalar product is commutative. What is meant by commutative? Commutative means vector A dot vector B is equal to vector B dot vector A. You can multiply in both the ways. Both will give you the same answer. Now, the second thing, scalar product is distributive over addition. See, distributive over addition means vector A dot vector B plus vector C. I just opened the bracket. So, it can be written as vector A dot vector B plus vector A dot vector C. Okay. Now, third, if two vectors are perpendicular to each other, dot product can be written as vector A dot vector B is equal to AB cos 90. And what is the value of cos 90? 0. Yes. So, 0 into any number is 0. Therefore, if two vectors are perpendicular, their dot product is 0. Look at the fourth property. If two vectors are parallel to each other, theta is equal to 0. So, what is cos 0? Cos 0 is 1. So, 1 into AB, AB. That means, if two vectors are parallel, then their scalar product has maximum positive value. So, dot product is having maximum value when they are parallel. When they are perpendicular, their value is 0. Now, if two vectors are anti-parallel, then what is the angle between them? 180 degree. Yes. And if the angle between them is 180, what is cos 180? Minus 1. Cos 180 is minus 1. So, A dot B is equal to AB cos 180. Cos 180 is minus 1. So, it is minus AB. Therefore, we can say that if two vectors are anti-parallel, then they have the maximum negative value. Don't think that negative AB is the minimum value. In vector, negative sign shows the direction. Okay, so if I ask you -5 plus 5, which is greater? You will say, in maths you will think like this and say, okay, plus 5 is greater, minus 5 is lesser. But in physics, in vector algebra, it is not like that. -5 and plus 5 both are equally greater. One is in the positive direction, other is in the negative direction. That is the difference. Negative direction does not mean that the value is lesser. Okay, so it is having maximum negative value. Okay, now next point. Scalar product of a vector with itself is equal to the square of its magnitude. Meaning, if I take vector A dot vector A, I can write AA cos 0, because I told both the vectors are same. Both are same vectors means angle between that vector is 0. So cos 0 is 1. So I will get the answer as A square. So vector A dot vector A is equal to A cos 0, which is A square. Okay. Now if I take I dot I cap, j cap and k cap are the unit vectors which is used to represent x axis, y axis and z axis respectively. So to represent a unit vector along x axis, we use I cap, and the unit vector along the y axis is represented as j cap, and the unit vector along the z axis is represented as k cap. So when I say vector I dot vector I, both are on the x axis itself and it is a unit vector, magnitude is 1. So 1 square into cos 0, answer is 1. In the same manner, I can write I dot I equal to j dot j equal to k dot k equal to 1. What about I dot j? I means unit vector along x axis, j means unit vector along y axis. So x axis and y axis, what is the angle? 90 degree. So what is cos 90? 0. So I dot j, the answer is 0, j dot k and k dot I, all of them are having the same value, that is 0. So when we do the dot product, we only need to consider the like directions. That means multiply only x axis and x axis, no need to multiply x axis and y axis because answer is 0. So whenever you do dot product, multiply only the similar axis. Now let us see how to multiply two vectors using this vector algebra. Okay, how to do the dot product of two vectors in vector algebra. I write vector A as Ax I cap plus Ay j cap plus Az k cap. We studied only x axis and y axis, but if I can split vector into 3 dimensions. So I can split vector into x axis, y axis and z axis in this format. Similarly, vector B can be written as Bx I cap plus By j cap plus Bz k cap. So I wrote two vectors. Now I am asking you to find vector A dot vector B. So what will we do? How will you do vector A dot vector B? I told you have to multiply only the like axis. That means x axis and x axis. So Ax into Bx. I into I is 1. I dot I is 1. So I multiply Ax into Bx plus Ay into By. Again j dot j is 1 plus Az into Bz. Again k dot k is 1. So we are only multiplying the like terms, and that will give you the answer for the dot product. Okay, that's all for today. Thank you.